Oh, this is session 27. We're looking at the pre-final, the odd numbered problems. First one asks to find the distance between the points 2, -3, and 4, -7. The first thing we do, of course, is to say, do we have a formula? And of course we do. And that's listed there as d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll then insert the numbers for x1, y1, x2, y2. It shows in the first two to be x1, y1, and x2, y2 the second here. And x2 minus x1, 4 minus 2, quantity squared, and y2 minus y1, -7 minus a -3. Be careful the double negative there. That's going to be a -7 plus 3 in just a moment here. -7 plus 3. Or -4 squared, and 2 squared out front there. That's total of 4 plus 16, or rad 20, and rad 20 is rad 4, rad 5, better known as 2 rad 5, and that's choice B. And again, I caution you that these are all multiple choice, so if you don't see the answer you're getting, go back first thing, check to see that you maybe make a mistake writing the problem. Maybe the formula is wrong. Other than that, maybe the plus signs, maybe you missed the plus or minus sign, or the arithmetic. Be careful, okay? So go back and check. The correct answer is there, and in this case is part B. Push on to number 3. Number 3 says to find the equation of the line perpendicular to this line, -4x plus 3y equal to 4, and also with a y-intercept of 3. What I did was, if we're looking for the equation of the line, write the formula for the line, y minus y1 equals m times x minus x1. In this case, we could have used y equals mx plus b. I chose not to do that because maybe we wouldn't have the y-intercept, we had the x-intercept or some other point, in which case we'd have to use this general formula. So I use the general formula anyhow, just in case in your particular problem you don't have the y-intercept, you have the x-intercept or something else, you'd be using this formula. And then if we're given y-intercept, of course, x is 0, y is 3, so x1 here is 0 and y is 3. And then we need to go ahead and find the slope here. And what we'll do is go back to the original equation that we're supposed to have our line perpendicular to, and maybe solve this for y by adding 4x to both sides, then after that divided by 3. Slope of this line is 4/3. If our line is parallel, our line also has a slope of 4/3. If our line is perpendicular, then it has a slope of negative reciprocal, or the opposite reciprocal, of -3/2. And we're told that 3/4. We're told that it's perpendicular, so we should in fact do take the reciprocal there, negative reciprocal, and that's -3/4 x. X minus 0, of course, just being x, so I eliminated the 0 there. This would be, maybe add 3 to both sides, you have a nice answer, or the fine answer as it is. The only problem is, of course, and that's maybe somewhat of a problem with multiple choice, is that you don't have sometimes the answer that's there in that form. So you have to sort of conform to the choices here. In this case, the choice in standard form with no fraction. So you probably want to multiply both sides by 4 here. You get 4 times y minus 3 is equal to -3x. And then after you distribute there the 4 to both the y and the -3, and maybe add 3 to x to both sides. Looks like 3x plus 4y equal to 12 should work. And you may want to go back and check to see if you let x be 0, if y in fact is 3, that should be certain, okay there. And then check to see if the slope also is a negative reciprocal. If that's the case, then you know you have a good answer. So it looks like part C should be the answer for number 3. And number 5 I've separated already. Number 5 says to find the center and radius of this equation. And we're looking for the equation of a circle. We're given the equation of a circle, looking for the center and radius of that circle. So what we want to do is to leave a space between the x here and the y squared, and also between the y and the equal sign. I subtracted 31 from both sides. You should know at this point we'd like to go ahead and complete the square here. All three of these in fact. Complete the square here for the -4x. Take half of the 4, which is 2, and square it. And also for the y, take half of the -12, 6. Again, we don't care about the negative or positive because when we square it's going to be positive anyhow. So it's 6 and then square that. We're adding 2 squared and 6 squared to the left. We should do the same thing on the right. Add 2 squared and 6 squared to the right. On the left side, again, I mentioned to you that we began the course with factoring, and now we're coming to the end of the course also with factoring. It didn't go away. We're going to factor the x squared minus 4x plus 4. The minus from here and the 2 from there. That's the reason I didn't change the 2 squared to 4, because the 2 will come back and so will the negative there. So it's x minus 2 squared, and the same thing with the y squared minus 12y plus 36 here. It's the minus sign here and the 6 there. So it's y minus 6 quantity squared equals to 9. The 9 came from the negative 31, and the 2 squared and 6 squared, 2 squared 4 and 6 squared 36, 40. 40 minus 31 is 9. So we'd like to conform this to our formula, x minus h squared, h of course is 2, plus y minus k, and again squared, k is 6, and of course this is r squared, and r squared then being 3, r squared being 9, r is 3. So hk, h2, k6, 2, 6, and radius 3. Good answer, and that looks like part B. Be careful, notice that the choices there for part A involve quite a few 2's and 6's, and also 3 and 9. Be careful which one you choose there. In this case, it turned out to be B. Okay, be careful with the signs. Number 7, I'd like to change this from the radian measure to the degree measure. Rather simple. You have a conversion factor for that. You want to multiply that by 1. In this case, 180 degrees divided by pi radians. Remember, there are 180 degrees for every pi radians. The radians will cancel for you here. And I just did a little bit of simple arithmetic. The pi's will go also. 2 into 180 is 90. And 90 degrees times 5 should be 450 degrees. And that's very simply A. Okay? So that's a nice quick one. Again, some are more involved than others. Some require a little more time. That's a nice quick one there. That should get us through 7. We're going to proceed with the others once I get all this off. You might want to take a look at 9, 11, and 13. We'll get those up just in a minute. For number 9, we'd like to find the exact value of the tan of pi over 6. You might want to change, as we did in number 7 just a moment ago, the pi to 180 degrees, and say this is the tan of 180 over 6 in terms of degrees instead of radians. That sounds like 30 degrees. And that's really simple. Back here in the trig foundational data here, we have the tan of 30 degrees. Looks like that's right, 3 over 3. So use all the resources you have there. In this case, radical 3 over 3 from our foundational table. And that looks like that should be part D for number 9. And do make sure that you use the foundational tables, your trig tables here also, and all the other data that you have available for you there on the Canvas files. for the exam here. And number 11. Number 11 says to find the equation for the curve. I would start with this situation, make the picture, and maybe start from the 0. I'd give you a little more than what you need there. Looks like something like that. That certainly looks like the sine curve, but you know the sine curve, of course, is here. So how about the negative sine curve? Okay, so I'd say that this is y equals to negative sine of bx in there somewhere. And we like to find out what the amplitude is. If you look at the curve, the amplitude looks like it goes up to about 5 and down to negative 5. So the amplitude is going to be 5 for us. So it looks like negative 5 should work there, negative 5 out front. And I'd stop there and take a look at the choices, and that's kind of the nice part about the multiple choice. As we saw before, sometimes you get a good answer, but the answer isn't there. You have to conform your answer to what the choices are. But another way of looking at the multiple choice also is the answer's there, so you can maybe take a look at that first. Unfortunately, if you look at the choices, all of them have negative 5 sign, don't they? So unfortunately, that's not going to help too much. We're probably going to have to go through it and find what the period is. If you follow the period, it looks like we're talking about increments of 1 pi, and it goes over to 6 pi. So the period, it turns out to be 6 pi. And I'm looking at no 6 pi there, so it doesn't look like that's an answer. What do we do with this? Well, how about considering what we're going to do with b, because it looks like b is nowhere in our choice. We have some relationship between the period and b, and you should know that we have a formula that says that the period is equal to 2 pi over b. So in order to find b, we're going to have to find what the period is and then solve for b. We found the period is 6 pi. Let's replace that period with 6 pi. And then what I would normally do would just be to interchange the 6 pi and the b. You can do it however you like. If you multiply both sides by b and then divide by 6 pi, I think you'll find you get this. You'll get b is equal to 2 pi over 6 pi, okay? Check to see if that's true. You want to probably multiply both sides by b, and that will reduce the b. So you have b times 6 pi. Divide both sides by 6 pi. It looks like this should be 1/3. So how about replacing that b now with a 1/3 and saying that that's a nice answer for us. Negative, you might want to put some parentheses around 1/3. Not necessarily check the choice anyhow. But it looks like negative 5 sine of 1/3 x should work for us. How about d? D a good answer for us for number 11? Number 11D? Now 13, we're talking about finding the average rate of change. And in fact, I didn't even ask you to write the formula down. The formula is already there for you, okay? The formula is there. Find the average rate of change here. All you need to do is to substitute, basically. F of x is given as x cubed plus x. So I'm going to change that f of x to x cubed plus x here. This f of x given here in our sheet as x cubed plus x. And finding f of 1. F of x here is x cubed plus x. And if we're looking for f of 1, let's go to replace the x with a 1 there. And f of 1 sounds like that's going to be 1 cubed plus 1 more. How about 2, okay? So f of 1 becomes a 2 there. And that's all over x minus 1. There's our answer right there. So if you take a look at the choices, and by the way, I'm assuming that you've already printed this off from the Canvas files, the math pre-final, which is there for you. Looks like, and when I'm looking at the answers here, it looks like D is a good answer, but the sign is wrong. D says x cubed plus x plus 2 over x minus 1. And here there's a minus 2. So I go back and check the signs first, and then we say, wait a minute, there's no way I can make that negative 2 a positive 2. So unfortunately, that's not going to be a correct answer, okay? So be careful again. you won't be able to come up and ask me, look, is this the right answer? Is there a mistake in the printing? There is a mistake in the printing. This is the right answer, but it isn't the choice. That's part D. The only other option is to look at A, B, and C and say, well, A, B, and C don't have a fraction there. Maybe we're going to have to divide this, okay? So this is my subtle way of having you divide this without saying divide, but checking to see also if you can do the division. So this is x minus 1 right here. And we're going to divide that into x cubed plus x minus 2. Leaving a bit of a space there between those because I figured that maybe I'm going to have an x squared in there somewhere. X times what will give us x cubed? X times x squared should work for us. And then we're going to multiply that x squared with both of these. We're going to say x squared times x is x cubed. And then x squared times a negative 1 is negative x squared. And then from our synthetic division and our long division, you should know what to do with that line. You'll subtract that line. Take the opposite there. You'll be left with x squared, and then we have our plus x and minus 2 here. And then same consideration, x times what will give you x squared? That's an x. So we'll put an x here. And x times the x minus 1, x times x squared, and x times the negative 1, negative x. And then we'll do the same thing we did in the previous line. We'll take the opposite of both of those and say the x squares will go, and 1x and 1 more x is 2x minus 2. And the last step then, how do we go from x to 2x, or x times what will give us 2x? That's a plus 2 there, positive 2. And let's multiply that 2 with both of those. 2 with x is 2x, and 2 with the negative 1, negative 2. That looks kind of nice because when we go ahead and take the opposite of that, we get 0, and guess what? Good answer above that. How about x squared plus x plus 2? And that looks like that's A, isn't it? Okay, so there is the right answer. The right choice is A. It is not D back there. D has the wrong sign for the 2. Don't fall for that. If it isn't exactly as you have, if you have the correct answer there, then go back and make sure you get the right answer. It's one of those. And this turns out to be A for number 13. After 13, we go to 15, and 15 is an exponential problem. It says that e to the x minus 2 is equal to 1 over e to the 5th, and the power x plus 1. And by the way, too, I probably would never have written it that way. I've written it that way only because to show you the procedure. And you realize you want to try to get the basic situation to get the bases the same if you can. If not, then we'll take the log of both sides, in this case probably the natural log of both sides. But before we do that, let's try the easy way, okay? Let's try to get the bases to be the same. And I think we can do it very quickly here, just by using the fact that the 1 over e to the 5th is the same as e to the negative 5. So now we really have the bases the same. We'll match the exponents. And we'll say the x minus 2 on the left here should equal to the negative 5 times x plus 1 here. How about negative 5x minus 5, okay? Negative 5x minus 5. Distributive property again, give the negative 5 to the x and give the negative 5 to the positive 1. Get the x's together. Up to you how you want to do that. You might want to subtract x from both sides here to go ahead and get all the x's together, or you could go to the left, whichever way you like there. I'm doing this. Since I'm going to the right here, I'll probably add 5 to both sides also to save a little bit of space there. On the left side, the x's will go, and you're left with 5 minus 2, which is 3. On the right side, this is negative 6x, and the 5's go. Divide by negative 6, looks like negative 2 should be a good answer for us, okay? And then you should be able to put the negative 2 back in here to check to see if that'll work for you, okay? Negative 2, let's see what we have for this. Oh, my mistake, not 2, right? Okay, because negative 2 is not an answer. Oh, that's too bad. Must be some mistake there. How about instead of negative 2, maybe you should say what? When you divide by negative 6. Divide by negative 6, maybe instead of negative 2, negative 1, negative 6. Negative 1/2? How's that sound? That's a little better, isn't it? Okay, so be careful. I would not skip steps there. Put the steps in, and maybe negative 1/2 a better answer, okay? And if you go back and check anyhow, if you put a negative 2 back in here, this would be e to the negative 4, and a negative 2 here, that'd be maybe when you go through this process, e to the negative 5. So not the same. I think negative 1/2 should work, okay? And we'll check that in just a minute. Do check the ones that can be checked. Don't just say, okay, in fact, in this case, I had to check because 2 wasn't there, so you want to go back and make sure, wait a minute, made a mistake somewhere. Mistake was dividing by 6 and not divided by 3, okay? A negative 1/2, let's try that, see if it works, okay? Do check to see if they work. You will have time for this. There's no reason not to. Negative 1/2 there and a negative 1/2 here. Probably easier to do it here if you want. This is e to the negative 2.5, e to the negative, or e to the negative 5/2, if you would. E to the negative 2.5 is e to the negative 5/2. If you have here as a negative 1/2 plus 1 is 1/2, and this one maybe call that 1/2 also, might be a little bit nicer there. Negative 1/2 plus 1 is 1/2, and when you change that to the e to the negative 5, negative 5 times, remember you take to a power, you multiply. Negative 5 times 1/2 is also negative 5/2. Same thing here. Looks good, okay? C is a good answer for us. We got the wrong answer first because divided improperly, but unfortunately the choice wasn't there. Even if the choice was there, you want to go back and check to see if it works, okay? If it doesn't work, go back, make a correction. Okay, that should get us through 15. Seventeen is next. The 17 is log of 5 plus x. And then minus the log of x minus 2 should equal to the log of 4. Excuse me, not log 4, log of 2. I was prepared really not to write this at all, but to say, look, I saw the minus sign there, and I hope you would do the same. There's no reason to write the problem as it is. You understand that the minus sign there should indicate when you're subtracting the log, same as dividing the numbers. So I would have written this step instead of what's above there. No reason to write what's there if you know that the first step is going to be to put those back together. And then we've said this a few times in the previous chapter there that if the logs are the same here, the numbers should also be the same, so that 5 plus x over x minus 2 should be the same as 2. Again, we're not dividing by log here. What we're saying is that by virtue of the equal sign, whatever's on the left must equal to what's on the right. So if the logs are the same on the left, the numbers following should also be the same. And then maybe you want to multiply both sides by x minus 2. 5 plus x equals to 2 times x minus 2. Distributive property again, 5 plus x is equal to 2x minus 4. And then maybe subtract x and add 4. I would do that probably. Save a little step there. Subtract x from both sides. That'll give you x here, and add 4, 9. I'm going to go back and check it anyhow, okay? Probably check it at the second step here, assuming I did the first one right. You can check it on the first one too, but it might come out to be a little bit more obvious here in the second step. If x in fact is 9, and 9 and 5 is 14, and 14 divided by 7 is 2, that's good. The log of 14 over 2, the log of 2 does equal the log of 2. 9 is a nice answer. And check to see that for this one, number 17, it should be B, but take a look at the answer for A also, okay? A is a negative 9. And then, of course, the other two answers are totally wrong, but be careful with your signs again, okay? And most important there, you miss a sign there and you lose 2.5 points, or 2.5 points apiece, or 40 problems. So you want to make sure you have to do a good job with the signs also, okay? B, answer for number 17. Number 19. 19 says, determine the annual decay rate of a radioactive isotope with a half-life of 277 years. Really easy problem. We want to determine the decay rate. Decay rate, we're talking R, and you should understand there's a formula for that at ln of 2 over t. That's our continuous decay rate. And we're going to talk about then ln of 2. You know that we've done that many, many times now. 0.693. And the number of years, in fact, we're doing this for is 277 years. So it takes a while for half of that radioactivity to be released here. Ask you to do a bit of division on this. It doesn't have to be difficult. I know there are 3 numbers there, but let me show you how easy this can be. The decimal isn't going anywhere, just above the bar, and 277 will not go into 0. It won't go into 69. It will go into 693. This is almost 300, and that's a bit over 600. So I'd probably say a 2 there, okay? 3 is going to be a bit too big. If this was 303, that's about 900, so a bit too big. I would stop right here. You can make a decimal percent out of this by moving it 2 places. It's 0.2%, or thereabouts, okay? There's going to be some more to that. I wouldn't necessarily do it now. Maybe later when you're finished with the exam, go back and check and see. I want to make sure I have that's a good answer there. But a rough answer, I've tried to get you to estimate here. A rough answer might be 0.2, and there's only one answer, one choice there with 0.2, and it's 0.25%, okay? 0.25%. So if you carried this out a bit further, I think you would find that it would be a 5 there, and when you moved it 2 places, you get 0.25%. So I wouldn't necessarily do all the division there. Take a look at the choices there, and then maybe take a hint from your choices to which one they might be. Obviously, you might have the wrong answer, but if you've done a good job here, the right answer is going to be obvious for you. And in this case, that's going to be D. Okay. So 0.25% for the answer for number 19. Don't do all the arithmetic, you do a little bit of estimating there, and then go back and check it later on. Number 21. The 21 says a form of polynomial with zeros of 2 multiplicity 2, 2 multiplicity 2, and also a negative 2 multiplicity 2. And it's said then to have a degree of 4. You know what happens here, we're working backwards. We're saying if you have 2 multiplicity 2, that means we have 2 answers with x is 2, and we also have 2 answers with x is negative 2. And then if you proceed to work backwards from there, say what happened before we had those answers? Well, we had factors. We subtract 2 from both sides. We had x minus 2 equal to 0. In fact, I won't have enough space to write all this, so I'll just say that the first thing we had was x minus 2 equal to 0. And then we'd subtract 2, and x minus 2 also equal to 0. And here x plus 2 equal to 0. And x plus 2 are also equal to 0. Basically, we would say if x minus 2 is 0 right here, we'd add 2 to both sides, x would be 2. Again, x minus 2, x would be 2. Here, x negative 2 and negative 2. We'll change the 0 in a moment to f of x. But again, you will not see this as a choice, I don't think. If you check the choices are in expanded form. I try to give you one that you could expand without too much effort. And again, if you take a little hint as what we've done before, you can make it a little bit easier for yourself. I would not go from left to right multiplying. I look for these two, x plus 2 and x minus 2. That should give you a perfect square minus a perfect square. These are the factors, the difference of squares. If you multiply those, the middle term will fall out. I think that'll be x squared minus 4. Check to see if that's the case, all right? And then the same thing will happen here with the other two. The other two should give you the same, right? The same x squared minus 4. So if you do a good job on this, you won't have to do so much multiplying. FOIL this, the first two x4, the outside and the inside negative 4x and negative 4x, negative 8x squared there. And the last two are positive 16. And then normally we'd say equal to f of x, and that should be a good answer for us, okay? So it doesn't take too much effort to do that, it's just a matter of getting a procedure, knowing what to do. And I think that's going to be C for us. Again, I caution you, take a look at choice A. Choice A, the only difference between choice A and choice C is that A has a plus 8x squared instead of a minus. So again, be careful with your signs. 23, I might be able to fit here. We'll just take a look, okay? 23. 23, we're looking at the function f of x equals to negative 5x squared plus 10x. And we'd like to find out, first of all, whether this is a max, whether there's a max or a min for this. And secondly, what in fact is that a max or min. You should be able to look at that and say, I know automatically that it's a maximum value, right? It's a maximum because of the negative here. The negative will mean that the curve is opening downwards. So we're talking about a maximum value there. So there are two choices, I think, with maximum and two min. So obviously the two min choices, B and C, are out already, right? So you kind of eliminate those two. Let's go ahead and see what the value is so we can determine whether it's A and or D. We find that for this is parabola, for the parabola, the maximum min is going to be at the vertex. So vertex we found before as negative b over 2a, comma f of negative b over 2a. Here a is negative 5 and b is 10. C would be 0 if we needed it, but we don't need C at all. We just need B and A. So negative b over 2a, how about negative b is negative 10 over 2a, 2 times the negative 5. So we're looking at basically negative 10 over negative 10, and negative 10 over negative 10, it should be 1. And if you check the C, I think there might be a choice of 1 there. In fact, it looks like D, but you want to be careful, okay? Because this 1 is not the maximum value. What we're saying is that when x is 1, then we'll have the maximum value up here somewhere for the curve. So we need to find f, the f of the negative b over 2a. We need to find that because that's going to give us the y value, and that's going to be the max or minimum value. In fact, whenever we get here, we'll say that when x is 1, we will have a maximum value at whatever that is. So going back to find out what that is, just replace the x here with a 1, okay? We found x is 1, so put a 1. I'll replace it here, but you should be able to do it in your head there. A 1 there and a 1 here. And this is negative 5 times 1 squared. Negative 5 times 1 squared, negative 5. And 10 times 1 is 10. So 10 minus 5, sounds like 5 there, okay? So at the point 1, 5, when x is 1, we will have a maximum value of 5. So our answer here, max at 5. And I think that's going to be A, isn't it? It in fact is, okay? So it's A. So be careful with this one. You will get 1 when you find the x value. The x value is not the value of the max or min. It's the place along the x, the number along the x, where you will get the max and min at y. So be careful with that one. There's 23. And we're going to go on to number 25 next. 25 is a composite function. So while I'm erasing here, you maybe want to begin to work on that one and check to see what you get for the composite function. There it goes. It should be relatively easy. It's a double substitution situation. 25 says to find f circle g of x. And given that f of x is 4x plus 7, and g of x is 5x minus 1. So we're looking for the f of the g of x. Remember, this is another way of writing the f circle g of x. So what we're doing is we're taking the f function right here, 4x plus 7. We're taking that f function and we're replacing the x in that f function with the g of x. G of x being 5x minus 1 right here, okay? So I'm going to do that. We're going to say 5x minus 1 in place of the x on the right. Basically nothing more than distributive property and simplifying, that's about it. When you distribute that 4, that'll be 20x minus 4 plus 7. It sounds like 20x plus 3 is a good answer for us. So nice and quick. There's not too much for that one. And there's only one choice. Well, all of them have 20x. Just have to be careful with the number behind. It looks like B should be a good answer for us there. So how about D for number 25? Okay, 25B. 27. Now 27, we are looking for the arc length of a circle, okay? And it says S there already. Hopefully you know the formula. If you don't, the formula is R theta or theta R. If you don't, again, that's why I put this together in the 2-page trig foundational data, okay? It's back there on the second or third page, I think. I'm going to take a look. S equals R theta. So for number 27, R is given as 13.3 and theta is 3.5. Just substitute and you're finished, basically. Find the right formula. Theta is 3.5 radians, that's given. And R is 13.3, 0.38 in fact. And I would kind of stop there and take a look at, before I even worried about multiplying, 3 times 13 is 39. It's a bit more than 3, a bit more than 13. I'd say it's over 39. You'd be somewhere in the area of 40, 45, something like that. I would check to see what the answers are, and it looks like B is the only answer that's close, isn't it? And choice A is 4, nowhere near the right answer. Choice C is 10 times the right answer, it's 478. And point D also is, D is 3, very small too. So the only choice there, B, looks appropriate at all. I'm going to say B, okay? Now, B is, in this case, 46.8. And I would go ahead and say, if you want to, on a piece of scrap paper somewhere, go ahead and multiply, see if that's true. But again, I don't think you really have to do all that in the sense that you should see that the only answer that's going to be close is that one. And that should be B. And multiply it out, I think you'll find that's a good answer. Okay, so there's 27. 29? 29 says to simplify cosecant of theta, sine theta. I would hope that maybe you wouldn't even have to write this, okay? The cosecant of theta times the sine of theta. We just finished the previous section talking about this. You want to find a relationship again. I think that your trig foundational data is very nice. I don't expect you to remember all these. It'd be nice if you do, but they're there for you, so you don't have to memorize them. The cosecant and the sine are reciprocal functions. So cosecant is 1 over the sine. And multiply that by the sine, and what do you get? Not 0. How about a 1, okay? I'm not saying not 0 because, well, in fact, 0 is a choice, isn't it? Isn't 0, but A instead. A, the choice for number 29. That should be 1 as our answer, not 0. Remember, any number divided by itself is 1. 31? Now 31 is the exact value of sine of 2 pi. Another one, very, very simple. Again, I would point out to you that I haven't arranged this so that the most difficult are at the end. I just threw those all in. Half the test is trig because we don't have a trig test for the previous chapter, and the other half is the review. So this is the trig part of it. I would just look at the picture again on the back of your trig. Well, again, I say in the back because I put this together in 2 pages. And it'd be the 4th page on yours if you took it off the files there. The sine function looks like this, and at 2 pi, it's right there, isn't it? it's 0 or 2 pi. Or you can think of it as 360 degrees. There are a few ways of doing it, but I think that the picture is very, very nice. How about 0 as a choice for us, okay? And that was our answer. And that, for number 31, it should be, in fact, should be C, shouldn't it? Okay, so 31 is C. The picture is very useful. Use it. 33. Now 33 says in which quadrant is a cos of theta less than 0? Cos theta less than 0. And also the cosecant of theta less than 0. Okay. So you want to know where the cosine of theta is less than 0 and the cosecant of theta less than 0. I haven't talked much about cosecant, but they kind of follow a bit here. It wouldn't have followed that closely if we were doing odd and even together, but since we're separating these, they can come right on each other's heels there. The cosecant is one of the signs, so basically if we're looking at the SIGN, positive or negative value of the sign, we're also finding the SIGN, the positive or negative value of the cosecant. They're the same. In other words, had this been cosecant of theta is maybe a negative 5 or something like that, then the reciprocal 1/5 for the sign would also be negative. They have the same SIGN. So basically, we're looking at cosecant as the same as if it was sine. Because again, one is reciprocal, and in the reciprocal, they will have the same SIGN. So where are the sine and cos both negative? Well, I'll give you a little table for that. That's going to be STC and STC. The signs are positive here, cosine is negative here. It looks like only in the third quadrant do we have no S and no C. So that looks like that should be a good answer. The third quadrant, both of these would be negative. So how about C for that, okay? 33 is choice C. And I had the choices there, 1, 2, 3, 4, A, B, C, D. So 33 should be C. Another quick answer using the data that you have. 35, the next page, I shouldn't even have to write down. I'll do that, but you should be able to look at the answer and get the answer. Y equals to -4 sine of x. And 35 says to find the amplitude here. And the amplitude, I did not give you the obvious wrong answer as -4. The amplitude, remember, is the height or depth of the curve. The minus sign here is only useful to tell us the curve is upside down or right side up. So basically, the 4 is the amplitude, not the negative. And there isn't any -4 there anyhow. I wasn't that nasty with you. There's only one choice, it's 4. The first choice, A, is -4 pi, not right. The only choice that's correct is C for this, okay? C is 4. The amplitude is 4, not -4. 37 is one that I'm not sure I can fit in here. We'll see what happens. I guess maybe 37 and 39 we could probably do. Let's see if we can do that. We'll try to fit 37 here if possible. 37 says to write the equation of the sine function with amplitude 3 and period 5. Well, sine function y is equal to a sine of bx. Remember, there's a much more involved one on your foundational data sheets, about page 3 or so there, with the C and the D, but your author doesn't deal with that. We're just talking about A and B here. So all we need to do is replace A and B and we're finished, basically. And for 37, we're told the amplitude is 3. So I'm going to change that A right here to a 3. And then we need to find B. And if you insert B as 5, you might be able to look for a right answer there. And guess what? I don't see that answer. That's not right anyhow, but I was just checking to see if I gave you a wrong answer there. 5 is not right. It says the period is 5, and oh, my mistake, there is one. C, but C is not the right answer, okay? Yeah, C is a choice there, not right. We talked about the period a moment ago back in the far left board there. The period is 2 pi over B. Don't insert, we're given for our statement, we're given for a statement that the period is 5. So this is not 5. I didn't have a PD there before. I had a B there before I put the 5 in. There was a B. We need to replace that B with the proper information. We're told that the period is 5, not B. So we need to go back to our situation here, period is 2 pi over b, and say, let's replace that PD with a 5, okay? Let's do that, and we'll solve for b. We did this a few moments ago in another problem, I think. I would again interchange the b and the 5. You can go ahead and multiply both sides by b and then divide by 5. I think in either case you'll get b as 2 pi over 5. Okay, check to see if that's true. If you just interchange those as a proportion, or if you multiply both sides by b, it gives you, let me just put it in, I guess, and they give you 5b, divide by 5, and you get b equals to 2 pi over 5. So how about b is 2 pi over 5? Replace the b with 2 pi over 5, and that should be your answer, okay? b is 2 pi over 5 here, times x. And then check to see if that's a choice. So don't be so cavalier as just to insert the 3 and the 5. You want to make sure that you're inserting the right values for the right things. And 5 is not b, 5 is the period you need to find b. That looks like, I'm looking at d here, I think, 3 and then sine of 2/5 pi x. Looks good, okay? So it looks like d should be a good answer for 37, okay? D is a good answer. Do not fall for the C. C is not right. It doesn't have the proper numbers there, okay? Last one, I'm going to try to fit in maybe at the top here, so we don't have to go back and spend time erasing the entire board. 39 says this. It says you want to find the exact value of the inverse cos of -1, okay? And I kind of gave you some information about this before, that what the inverse cos means. The inverse cos, your author doesn't do this way. Instead says this: the inverse cos is the angle whose cosine is. Angle whose cosine is. The angle whose cosine is. In other words, your author does it this way: the cos of what angle is equal to -1? What angle here has a cosine of -1? That's what we talk about when we say inverse cosine. And this is the reason we talked about inverses too a while back in the other inverse chapter. Well, I would go ahead and maybe take a look at the picture again. Try to indicate that sometimes the pictures are very nice here, especially 31 and 33. Let's look at the picture for the cosine, okay? We can do it with tables and other methods, but the cosine looks like this. And remember, the amplitude is from 1 in each case, so it goes up to 1 and down to -1. If we look at the cosine -1, I think it's right there, isn't it? Cosine -1 looks like that should be right there. That's 180 degrees. That's 180 degrees. So I'm going to say 180 degrees for this one. Or, in fact, maybe, let me put the 180 in here somewhere, get rid of this maybe. How about 180 degrees? And then check to see if that's a good choice for us, okay? 180 degrees. Let's see what we have. For the choices, at 39, and 180 degrees isn't there, is it? In terms of radians instead. And I think we did this before, I don't have it on the board now, but 180 degrees, what's the relationship? There are pi radians per 180 degrees. So if it's 180 degrees, it's also pi. And I think, again, if you look at the table here, or not the table, but the picture on the trig foundational data, I think you'll find that I've done it in terms of radians there, so that in fact it should have pi back there anyhow. So how about pi is a good answer for us? And pi is going to be B for number 39. Okay, B. And we finished half the pre-final for us. Take your time. You will have 2 hours and a half, I think, or more, maybe even 3 hours to work on this. So there's no hurry. I don't know how long it took us to do half here and talk about them. But I presume if you took your time, you probably could do a good job in a lot less time than that. Important to make sure that you have all the data before you here for the trig foundational data, your trig tables, and anything else that you think might be useful in the way of notes or paperwork items that I gave you. We'll be looking at the even ones for the next session, and then we'll say we're finished with it and you've done a good job of completing the course. Okay? So that'll end then session 27 for us, for the pre-final, the odd-numbered problems. Again, when we come back to our conferencing, ask you that any questions I try to put every step or most of the steps in there, and some of the multiplication, maybe not, or division. But if you have any questions in the conferencing, let me know, please. Don't be hesitant. We're happy to see you there. Take care.